Hi everyone. We are going to start on probability, but before I get moving on that, I'm just looking at what the weather might be like this week. Right now it's 10 degrees and raining. That's kind of what they thought it would be. So I just want to look at the long-term forecast. Okay. Rain, what does this tell me? Rain, light rain. Interesting. 14-day, Sunday, 100% chance of rain. Monday, 40%. Tuesday, 40%, 20%. Okay, that's kind of interesting. And you're probably wondering, why am I looking at the weather when we're talking about probability? But the percentages here for precipitation, they are probability. You look at it and think, might it rain? Now, when they're saying it's 100% chance of rain, it's going to be raining. If they are saying it's 40%, well, it might rain, it might not. And then when we get to 20%, it's more likely that it won't rain than if it would. So this all has to do with probability. And within probability, we have something that's impossible to happen, something that is certain to happen, and then varying degrees of whether it will happen or not. So if it's something like equally likely, that's kind of maybe it would happen. Very unlucky or improbable, it's no chance. And very likely that something will happen. Okay, so for example, if the weather forecast in June, what are the chances of it snowing? Well, it'll be highly improbable, bordering on impossible. It has snowed in June, but it's pretty much impossible. If you go outside in winter, the chances of it being a cold temperature, like between -1 and -50, you're pretty certain that's going to happen. So there are different likelihoods that happen. Now, probability is used to forecast weather, and it's also used for when you're playing games and that. Okay, so what I'm going to have you look at is this page that's in your booklet. Okay, so they're asking us, read each statement carefully, choose from the terms to describe each event, and record your answer in the space provided. So you could either record it as certain or sure, impossible, likely, probable, unlikely, improbable, maybe, or uncertain and sure. And just keeping in mind of this number line. Okay, so the first question is, a flipped coin will show tails. Okay, so if you know a coin, it's head or tails. So this one is a 50-50 chance, so it is a maybe. Oh, I'll be in school tomorrow. Right now, that is very, very unlikely to happen. Okay? Or impossible. Now, if this was our regular school year, yes, we would probably be in school tomorrow if it was say a Monday. But since the schools are closed, we're not going to be in there. It will not get dark tonight. Oh, well, what happens at night? It gets dark. So for it to not get dark, that is impossible here in Saskatchewan. But if I lived up in Yellowknife or Whitehorse, where they will soon have 24 hours of sun, that would change. But for here in Saskatoon, it won't. I will have pizza for dinner tonight. Now, that could fall under the likely or unlikely. Okay, it depends. So if you ask your mom and dad, what's for supper tonight? And they say pork chops, well, you're not going to have pizza tonight. All right. So this one, it all depends on what you're having. For me, I'm not having pizza tonight, so this will be unlikely. Roll a 3 using a number cube. So a number cube is like a dice or a die, okay? And rolling a 3 is a 1 in 6 chance, so that is unlikely because there's a greater chance of rolling another number. Will it snow in June? Impossible. The teacher will write on the board today. Well, this one again, impossible since I'm not in school. January will be cold in Ontario. Yes, it's certain. My dog will bark. Certain. I will get a level 4 on my science fair project. Well, we won't do this one because we're not doing a science fair project. Okay, so this is the thinking you're going to use a lot in your dealing with probability. It's what's going to happen. Is it going to be certain? Is it going to be a maybe? Very unlikely, likely, or impossible. Okay, so what we're doing next is we're going to look at the predicting probabilities. And we have different things with probability. And the first part here is we're going to do an experiment. An experimental probability is a fraction or ratio that compares the number of times an outcome occurs in an experiment with the total number of times the experiment is done. So for example, if a head occurs 6 times out of 10 flips, the experimental probability is 6 out of 10, or this, or this, okay? That's when you actually do it, all right? Now, the probability of getting a heads on a flipping a coin is actually 1 out of 2. That's theoretical, and that's going to be the next page. So in theory, you should get heads half of the time. So if I flipped it, in this case, 8 times, I should get heads 4 times and tails 4 times. That's in theory, but when we get down to the experiment, it could change, okay? So we're gonna look down here. We're gonna roll a die 12 times, okay? So before starting, predict how many times you might roll a 6, about how many times. Now, predicting, well, I have 6 outcomes on the dice. I have, could be a 1, could be a 2, could be a 3, could be a 4, 5, or 6. So how many times might I roll a 6? I am going to predict 2 times. So now I'm actually going to carry out the experiment. So I'm going to roll once. I'm going to put a ticky here, 1 on the 1. Whoa, at the 2. Oh, a 4. Oh, a 6. Another 4. Oop, a 3. Oop, another 3. 2. Another 2. Another 4. Let me do a quick count here. We've got 3, 6, 8, 9, 10. 2 more rolls. Ooh, got the 6. And another 4. So how many times did I roll a 6? Twice. I matched my prediction. But I bet you did not think my 5 would not get any, or that I would roll a 4 times. So suppose you rolled the dice 24 times using the results from your experiment to predict how many times you would roll a 1. So in 12 times I rolled it once, so if I'm doubling it to 24 times, I probably will get 2 times. Okay? Now, you guys can try the flipping the coin. You're going to flip a coin 8 times and you're going to record what you got, how many heads and how many tails. Remember, in theory, you should get a head 50% of the time. Okay? We're going to take a look at theoretical probability. Okay, so first of all, we have an event. An event is a set of one or more outcomes in a probability experiment. So for example, the event of rolling an even number on a die includes the outcomes 2, 4, or 6. Now remember, die is 1, okay? Theoretical probability is a fraction or ratio that compares the number of ways an event can happen with the number of equally likely outcomes. So an outcome is actually what happens in probability. All probabilities range from 0 to 1. For example, the theoretical probability of rolling an even number on a die is 3 out of 6 times. Okay, that would be half. So it's between 0 and 1. To figure out the theoretical probability of an event, follow these steps. Identify all the results that could happen. So that's the possible outcomes. Identify the number of outcomes that give the result you want. And then use a fraction or ratio to compare the number of desired outcomes with the number of possible outcomes. So in this case, when they said, what's the chance of rolling an even number? Well, my even numbers are 2, 4, and 6. So that's 3 numbers. And the number of dice here, the number of the numbers on the dice are 6. So there's a chance that I'm going to roll an even number 3 out of 6 tries. Okay? So, this is theory. Sarah put 2 red marbles and 4 green marbles in a bag. She reached in and took one out without looking. Now, how many possible outcomes are there? Okay, so she has 2 red marbles. So she could get a red marble 2 out of, well, how many marbles are there in together? 2 and 4 gives me 6. So for red,